Okay, all right, so we're going to start this lesson, exercise 14b, counting ordered selection. This lesson we're going to talk about the multiplication principle. We're going to also talk about the permutations, where the order is important when you rearrange something. And then we're also going to talk about the permutation with restrictions. Okay, so first we're going to talk about the multiplication principles. Now we've done the multiplication principles in the last lesson, where you multiply by the number of different arrangements together. So I'm going to give you a very simple sort of a revision here. Okay, so for example, if we have 1, 2, 3, 4, 5 letters, and then I'm going to choose like 4 letters that only. All right, so we've got 5 letters, but I'm going to choose, 4 letters and arrange them. All right, so and then if the order is important, all right, the question is how many different arrangements we can have, right? So if we use the multiplication principle, and we can also use the boxes for multiplication principles. So right now we have 4 boxes, as you can see here, and these 4 boxes representing the 4 letters I'm going to choose. Now with these 4 boxes, just making the box in roughly the same size. Now we have 4 boxes, right? Each box representing a letter you can choose. Now right now I have 1, 2, 3, 4, 5 letters, right? Out of these 5 letters, we need to choose 4 letters, and then the order is actually important. So when I say the order is important, which means AB is different to BA. Okay, this is when order is different to, the order is actually important, and this is about a permutation. When order is not important, it's combination. We're going to talk about this a bit later. Okay, all right. So if we're using the counting, the multiplication principles, for the first letter that you can choose, you can have 5 different choices. You've got 1, 2, 3, 4, 5 different possible ways. You can actually place a letter in the first box. Okay, you can choose either A, B, or C, or D, or E. So therefore, for the first box, you've got 5 different possibilities to choose from. Then for the second box, you have 4 different possibilities to choose from. All right, since because you have already chosen one, so if you choose like a D, you only have 1 A, B, C, and E left. So you only have 4 letters left. All right, and then follow this idea, we can have like 3 and 2 choices. So therefore, if we multiply them together, this will be the total possible. Okay, so this is the total possible arrangement if order is actually important. Okay, so that's 5 times by 4 times by 2 times by 3. So the answer for this question here would be 20 times by 6, and that's 120 different possibilities. Okay, all right, so that's a pretty easy question to begin with. All right, it's actually really easy, to be honest. All right, so let's have a look at another example here. What happens if we have ordered selection, but then we can have repetitions, right? So right now, we can't really have any repetitions. So repetition is not really allowed. You can only choose a letter once. But what happens if we can choose the letter multiple times? Okay, so let me just put this one here. For the condition here, order is important. Okay, sorry. Order is important and no repetition. All right, so what about this time? We still choose 4 letters, and then we're going to rearrange them. But this time repetition is allowed. All right, so you can choose A multiple times. You can choose A several times, 3 times, 4 times, or just choose once. So if order is still important, but with repetitions, what is the total number of arrangements? Okay, so have a look at the same question here. Now this time, if order is important and also the repetition is allowed, then in that case, for the first box, you can have 5 different possible way of choosing the letters, right? A or B or C or D or E. And because we have, since we know that repetition is allowed, so once you have chosen the A, you can choose the A one more time. So therefore, we still have 5 different possible way for the remaining boxes. So in total, we have, 5 to the power of 4 possible ways of rearranging those letters or choosing those letters. Okay, and that becomes the total possible arrangements here. So in this case, as you can see, you'll have a definitely more possible arrangements if repetition is actually allowed. All right, it's because you can choose the A multiple times. All right, so there is sort of a formula that you can actually do. So for example, suppose that we have that R letter words that be formed from N distinct letters. If repetition is allowed, then the formula that is sort of describing this this situation is N to the power of R. Okay, N is just distinct letters, so they're all different, and R is just R lettered words to be formed. Okay, so N to the power of R. All right, so this is when the order is still important, and with repetition, so we can have repetition. Okay, we can have something that happens like multiple times. All right, okay, so this is using the multiplication principles here. All right, so it's actually pretty, I would say pretty easy. Okay, so I'll probably just try another example. So that's just the first example. All right, so probably the second example is about your like a PIN number, for example, like your credit card PIN number, your iPhone PIN numbers there. We can also find out the total number of possible arrangement there. So for example, for an iPhone screen lock, passwords, usually it's 4, but now I think they just like changed into 6. All right, but let's just say if we have an iPhone passwords, okay. All right, so now it's a 4-digit PIN, for example, or your credit card, your debit card or credit card or bank card PIN number here. Usually it's 4, but you can actually set to 6, I think. I don't know if you can actually set more, but 4 or 6. All right. So if it's 4, and then let's just say if we can only use numbers. All right. So numbers only. Then how many different possible arrangements are there if repetition is allowed? So for example, we can choose like 1, 1, 1, 1 to be our PIN, okay? And we can also choose 0, 0, 0, 0 as as our PIN. Obviously, I don't recommend everybody to using those pins there, but yes, you can. All right, you can do that. So how many different possible arrangements are there? All right, from number 0 to number 9. Okay, so right now, if you look at this, we've got 10 numbers in total. Okay, so 10 numbers in total, which means that for each of the boxes here, we can have 10 possible ways. If repetition is allowed, we can have 10 possible, possible ways to choosing those 10 numbers, right? We can either choose 0 for the first one or 1 for the first one. So we'll have 10 possibilities for the first, second, third, and fourth digits. So therefore, in total, we have a total of 10 times by 10 times by 10 times by 10, or 10 to the power 4, which in this case, we should have 10,000 different combinations of passwords, okay? Or 10,000 different combinations of key, of the PIN. Which is still a lot, okay? Which is still a lot. Usually, to guess that, it's sort of like impossible to guess it. The chance you can guess a random PIN number with a 4-digit PIN correctly is 1 out of 10,000. All right. Oh, that's not 10,000. Right, still it's still pretty I would say still pretty very small chance to guess it correct, right? But then if you look at this, if we increase that to 6, all right, digits, as you can see, if we increase that to 6 digits, and then that according to the same method here, that just becomes 10 to the power of 6, which you have like 6 zeros at the end. So now the chance is increased from 10,000 to 1 million of different combinations. So definitely it's much harder to find your p numbers or guess your p numbers just based on random guess, right? Because you have in this case, if you're using the 6 digits, you have 1 million of different combinations. Okay, all right, and then for example, if you want to set a password, like if it's a 6 characters, okay, so if your internet password, any password, if you set up with a 6 characters, for example, now with 6 characters you can have 10 numbers, you can have 26 letters, or actually 26 letters times by 2, 52, because you can also have capital letters. Then you can have some special characters, okay, like for example the hashtag, $sign, including all of those. Then you can actually do some calculation. The more obviously, the more different combination of numbers, letters that you do, the harder for for other people to actually find your passwords. Right, so I actually use this method to calculate the number of possible arrangements, and this is called a multiplication principle. Okay, all right, so let's move on. Okay, let's move on to the actual permutation. Okay, and what is a permutation? All right, so let's move on. The general case. All right, permutation. All right, so what is a permutation? A permutation or the ordered set is just arrangement of objects chosen from a certain set. Okay, so for example, if we have A, B, C, D, and E, all right, from this set here, if we want to choose 3 letters to form a set, okay, so therefore, choosing any 3 letters, then A, B, C, all right, A, C, B, E, C, D, we can have so many different possible ways, okay, and these are just the sum of the permutation of the 3 letters taken from the 5-member set, okay. So permutation or ordered set is just arrangement, all right. So the important words is the arrangement. Ooh. Uh-oh. All right, here's an arrangement. Okay, of objects. All right, chosen from the certain set. Okay. Okay, so what does that mean? For example, all right, let's just use the same example here, okay? We've got 5 letters, so we've got a set A, B, C, D, and E. We've got 5 letters here, and then we want to choose a set, okay? And then we want to choose 3 letters, and we want to find out what is the possible arrangements there, okay? 3 letters. Okay, now choose 3 letters. Okay, now from previous understanding, if we were choosing 3 letters, we can just simply using the box method here. 3 letters. So now for the first letter, we have 1, 2, 3, 4, 5, 6. 6 different possible ways to choose it. So therefore, that's 6. That would be 5. That would be 4. We can only choose this one once, right? So therefore, the answer we get is actually 6 times by 5 times by 4. And that's 120. Okay, that's 120 different possible ways. Of course, you can actually list every possibility. So if you want, and that's just going to be a lot of them. Right, there'll be 120 different possible ways. Because remember, A, B, C, A, C, B, they're all different. Okay, and you can have a different combination. Then you can have A, B, D, A, B, E, and it goes on. All right, so you will have so many different ways to do it. So therefore, listing is not a good method. Okay, it's definitely not a good method here. Okay, so now there's a quicker way that we can also do this question instead of using the the multiplication tables. All right, so there's a better way of doing it. It's actually using the notation of this symbol here, NPR. Okay, so this symbol is used to denote the number of permutation for R letters are chosen without repetition from the set of n distinct letters. So basically this R just tells you, hey, I've got a total of n distinct letters. I want to choose R letters from n distinct letters. What is the permutation of that? Okay, so if we have, in this case, the question here will be n is just equals to 5 distinct letters, and R is just equal to 3. I'm only going to choose 3 letters from there, so therefore the answer to that is 5p3. And if you use your calculator, there's a key on your calculator, I think it's just next to the division key. All right, so it's the multiplication key, and then on top of it, it's written as npr. Alright, so you just have to use the shift function to actually get that key out. So press number 5, press shift, and then you press that key here, and then you press number 3, you should be able to see that. Alright, and then you press equal, that gives you 120 straight away. Alright, and that's what the this notation is about. Alright? Okay, now once you understand this, then the next things you need to understand is what is this notation is really about. Like, how do we actually convert this notation into another formula? Right, so this NPR is also equals to n factorial over n minus r factorial. Okay, this is something that's it's pretty important. Now, why it is equal to n factorial divided by n minus r factorial? Okay, what's a reason for that? Okay, so if we think about the previous example here. All right, let's just look at the previous examples. So we've got 5 letters. We're choosing 3 letters at a time, choosing 3 letters, and then we rearrange them. All right, so the chance will be 6 times by 5 times by 4, which now is equal to 120. And how come this also works? All right. All right, so let's just have a little play, okay? So we've got 3 boxes here. All right, we can have more if we are looking for like more letters. All right, let's just have a few more, okay? Just do more. Okay, now for the first letter, okay, this one is just the first one. That's the second letter. That's the third one. That's the fourth one. All right, and then this is the last one, last letter. Depends like what's R equals to. Okay, now obviously for the first one that you have like n number of ways, right? N just representing the total number of distinct letters. So obviously for this question here, n is just equal to 6. All right. Then for the second one is n minus 1, and in this case it's just 5. And then we'll keep going n minus 2, n minus 3. Okay, so we can continue for this. And then the pattern, as you can see here, is if that's a 2, that's a 1. If that's a 3, that's a 2. If that's a 4, that's a 3. So it's always different by 1. So therefore that gives you n minus r plus 1. All right, it's always different by 1. If that's r, and that's negative r plus 1. Okay. All right. So, so that, according to my question, our question here, we stop at this 4 here. So that just equals to 4. Obviously, we can continue for that, right? So in this case here, the NPR, that formula, NPR, is just equals to n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, multiplied by ... until n minus r plus 1. All right. Okay, all right. So then, this one, let me just move this one a bit over to the front. Otherwise, I just don't have any space. All right. All right. So then, what we can do is we can actually write this one in terms of the actual, what is that called? The actual fraction. Sorry, let's have a look at this. Okay. So we can try to do it this way. Alright, so for those of you who actually don't understand what I'm doing here right now is have a look at this expression here, alright, and now have a look at this fraction. Alright, so let's just compare, alright, I'm just going to do this one, alright, let's compare everything. I'm just going to highlight everything that's the same, alright, so this is the same, that part, this part is the same, here we go, that's still the same, that is still the same. Right, now for the remaining part here, where does this one goes, right? And then where the hell, where's this one comes from? All right, and how can we have those? Now remember this, all right? Eventually we're going to times. We're going to times until we're going to have a term that's n minus r, and then we're going to have a term n minus r minus 1, and then we're going to keep having more terms, okay? And then we times by 2, times by 1. So we're going to continue with the process. And then if we divide the entire things here, which is exactly what this one is equal to, we can cancel these two out, and eventually we will end up with the pot, the top part, okay? And that is the reason why we're having this. So therefore, we're going to end up with, for the numerator, we're going to end up with n factorial, and for the denominator, we end up with n minus r factorial. And this is just a formula. Okay, so please learn the formula here. It's very important. And then, so if you look at the previous example, n factorial, we've got like 5 letters, so 5 factorial. And then we divide it by 5 minus, we're going to choose 3 letters, so that divided by 5 minus 3 factorial. And then we end up with 5 factorials over 2 factorials. And that's like 5 times by 4 times by 3 times by 2 factorial over 2 factorials, which is equal to 5 times by 4 times by 3. And eventually that just becomes the answer we have previously here. All right. Now, I'm not asking you to do this question here, obviously using pen and paper, because there is no point of just doing 5 times by 4 times by 3. Using this method is much harder. We can just using the counting methods, or we can just write down the 5p3. I'm just using this example to demonstrate the formula for you, everyone. Okay, that's the reason. Okay, all right. Now, let's move on to some questions there. All right, so I'm going to start with the question when like, for example, then there is no restrictions, all right? So there is no restriction, they don't provide you any restriction. But before we do that, we also need to talk about a permutation of a set. So back to this. We've been talking about like NPR, but what's NPN? All right, what does NPN means? Now, NPN means the permutation of an entire set. All right, this is very similar to the previous lesson here. All right, so what does that mean? It's like you've got 5 letters, for example, or you have n number of letters, and then you're choosing all n of them, all right, and then you rearrange it. So in that case, if we just use the formula, that is n factorial over n minus n factorial, which is n factorial over 0 factorial, and we know 0 factorial is equal to 1, so therefore that is just equals to n factorial. Right, so the idea is like if we have a 1, 2, 3, 4, and 5, and you're choosing all these 5 letters to rearrange them, then we know from the previous exercise that's 5 factorials. Then we can also do something like 5p5. They are exactly the same. I'll still suggest you just using 5 factorials instead of 5p5. Okay, just easier. All right, now let's move on. Okay, so now I'm just going to start to do a few questions from the exercise, okay? It's very important this lesson that you understand the basic idea about a permutation. I'm just going to record another part of this video here and then to talk about the restrictions. Seems the restriction is actually very important, and it's for, so you need to have different ways of dealing with the restriction questions there. Okay, so let's move on to the questions, examples. All right, so I'm just going to use the textbook question. And by the way, with the textbook question, this time you're going to do every single question there, okay? You need to practice. This is very important. All right, so we're going to do the question when there's no restriction, and then I'm going to talk about what happens if there's a restriction. I'm just going to going through different questions, okay? All right, so I'm just going to start with the first question here. Something that's really simple. List all the permutation of the letter of words dog, D-O-G. All right, the question asks you to list all the possible permutation. Okay, so that's easy. So we go D-O-G, we can have D-G-O. So once you have used the D, now you have O. Okay, so start with O. O-D-G and O-G-D. Then you start with G. All right, so you will have like 6 different possible permutations there. Now, remember whenever you really need to or have to rearrange and list all the possible permutations, in that case, make sure you do it, with a systematic approach. So start with the letter D first, and then you move on to letter O, and then you move on to letter G. Don't just do random one, okay? Because sometimes you just forget about the one. All right, so there are a total of 6 different possible ways to rearrange it. So 6 permutations there. All right, how do we do it? Like if we want to do the actual calculation, we've got 1, 2, 3 letters here. 1, 2, 3 letters here. They're all different, so therefore that's 3 factorial. That's another way to actually get to 6, which is 3 times by 2 times by 1. That's equal to 6. We can also do 3p3, and that's equal to 6 as well. All right, so that's something that's really simple, okay, without any problems. All right, again, as you can see, there is no restriction for this. All right, whenever we're talking about restrictions, sometimes I'll explain to you like in the next video about what is meant by restrictions. Okay, all right. Now, let's look at another one. All right, so let's just do a question when there is a restriction, but there's a really simple restriction. As I said, I'm going to record more videos in the future about restrictions. Okay, so let's just look at the words number, N-U-M-B-E-R. Okay, so we've got those letters here. All right, the question asks you, in how many ways can the letter of the word number be arranged? All right, so for the first one, okay, just how many ways all right, so this is the question. All right, so that's a really simple question, okay? Seems none of the letters are repeating themselves. All right, so therefore the number of ways we just count 1, 2, 3, 4, 5, 6. There's 6 letters here, so therefore in how many ways? Well, 6 factorial ways. 6 times by 5 times by 4 times by 3 times by 2 times by 1. Of course, you can use your calculator to work out what's the answer. That should be 720. All right, next. So we're going to do questions when there is a restriction. I know I haven't talked about a restriction, but I just give you some idea what's happening to the restriction question. And then I'm just going to record another lesson purely with just restriction questions there. All right, how many begin with the letter N? All right, so this is a very interesting one, all right? We have those letters here. Now the question says how many begin with a letter N. So when the letter is actually begin with letter N, that means you can't really change this one. All right, so this is actually fixed. Now, which means now we have 4 or 5 letters remaining. With these 5 letters, all right, you have 1, 2, 3, 4, 5 different letters. So with these 5 letters, we have like 5, 4, 3, 2, 1 different possible ways. So therefore, the answer is 5 factorial since you fix 1. All right, so that gives you 120 different possible ways. All right, questions say how many begin. Now this time another restriction. So how many this time begin with N and end with U. All right, so this time N and U is fixed, so we need to fix N and U. So N and U is fixed, we can't really change it. All right, however, what's in between we can change it. Right, so we have M, B, E, and R left in between. So with these 4 letters here, we can rearrange them. All right, so with those one, we will have 4 factorial different permutations here, and that gives you 4 times 3 times by 2 times by 1, which is 24 different possible ways. Okay, all right, so this is the kind of a restriction question. There is one more restriction question, which is question D. In how many ways N is somewhere to the left of U? I will quickly do it here, but then I will spend more time to actually explaining to you. All right, in how many ways, all right, is the letter N, letter N somewhere, it didn't say anything, but somewhere to the left of you. All right, so this becomes a bit tricky, okay? You want the letter N always to the left of you. So you can't have this letter U like an N on the right-hand side. It has to be on the left-hand side. So this is actually a bit interesting. So what we need to do here, again, I'll talk about like the technique a bit later, like, you know, in the next lesson. But then I'll just tell you, like in this case, let's just remove the N and U here. So just don't worry about these two letters here. Okay, let's look at the rest of the other letters. So we've got M, we've got B, we've got E, we've got R. With these four letters, okay, the rearrangement is 4 factorials. We know that, right? All right, so obviously we can rearrange those 4 letters around, you know, in different positions. Okay, so we can shift them around. So that's 4 factorial, you know, 4 factorial ways of rearrange them. Now what you need to do is you start to look at where you need to put the letter U. For example, if I put a letter U here, okay, if I put a letter U here, now N must be somewhere to the left of U, which means this is the first position just beside a U, but on the left hand side, all right, in between of R and U. So that would be the first position for N to be. All right, that's 1, 2, 3, 4, 5. So now we have like N can be here 1, 2, 3, 4, 5. 5 different places that's on the left hand side of U. Okay. All right, so multiply by 5 plus. But then this time, you know, remember, you don't have to put a U at the end. What you can do is actually putting U here. Now, if you're putting U here, then N can be 1, just in front of you, 2, 3, 4. Now, this time is 4 times. Okay, now you can continue this pattern here by keep shifting the U 1 place to the left, and you will end up with like 3 places for the N, 2 places for the N, and finally 1 places for the N, because if you put a U here, the only position for the N is just 1 that's next to, all right, that's in front of you. So therefore, that's what you do. You're actually adding all the possible ways, 5 plus 4 plus, plus 3 plus 2 plus 1. All right, so you end up with 4 factorials times by what is that equals to? That's 9 plus 6. So 4 factorials plus 15. Okay. All right, so if my calculation is correct, that becomes 24 times by 15, which is, let me use my calculator, 360 different possible permutations for this restriction, problem here. All right, now this is all about this is all about a very basic permutation questions. Again, as I said, I'll talk about a restriction in details in the next part of the video. Okay, thanks for watching. That's all. Thank you.